China just revealed a machine that doesn't belong in any category you already know. Not a helicopter, not a cargo plane, not a drone in any sense you've seen before. The R6000 heavy tilt rotor is something else entirely, and the rest of the world is only beginning to understand what that means. While other nations are still debating whether autonomous cargo aviation is even feasible, China is already flight testing a platform that carries 2 tons of payload, cruises at 550 kilometers per hour, and reaches destinations 4,000 kilometers away. Without a runway, without a pilot, without the infrastructure that every traditional aircraft on Earth depends on. This isn't an upgrade. It isn't an iteration. It's a different answer to a question aviation has been asking for decades. The R6000 doesn't just change what drones can do. It changes what flight itself is allowed to become. Picture a machine that lifts straight off the ground like a helicopter, then rotates its massive propellers forward and accelerates like an airplane. No runway needed, no transition pad, no ground infrastructure of any kind. Just vertical lift, a pivot, and suddenly you're looking at something flying at airplane speeds toward a destination hundreds of kilometers away. That's the tilt rotor concept. And at the scale China just built it, it becomes something else entirely. The R6000 is not a small machine. It is not the kind of drone you've seen delivering packages or filming coastlines. This is a purpose-built heavy lift platform with a maximum takeoff weight exceeding 6 tons. To put that in perspective, that's not a gadget. That's a working aircraft, one that happens to need no pilot and no runway to operate. Visually, it exists in a category with almost nothing beside it. The airframe is large, purposeful, and built around those defining rotors that give the tilt rotor its identity. Everything about the physical design communicates one thing: this machine was engineered to move serious weight across serious distance. What makes that extraordinary is how difficult tiltrotor technology actually is. Combining vertical lift with high-speed forward flight requires flight control systems of exceptional precision. The mechanical and aerodynamic forces involved in transitioning between modes are enormous. It's why so few tiltrotor aircraft have ever made it beyond the prototype stage anywhere in the world, and virtually none at this scale, and none autonomous. That's the detail that changes the entire conversation. Previous heavy tiltrotor programs required crews, required training, required the full infrastructure of manned aviation wrapped around them. The R6000 requires none of that. It lifts, it pivots, it flies. And right now, it's the only machine on Earth that does all of that at once. Numbers tell a story when you understand what they mean in the real world. So let's go through what the R6000 is actually capable of, and why each figure matters more than it might first appear. Start with payload. 2 tons of cargo. That isn't parcels or lightweight equipment. That's stretchers, generators, water purification systems, emergency food supplies, industrial components. 2 tons means the difference between a drone that assists logistics and a platform that replaces entire supply chain operations in the right environment. No aircraft in the autonomous cargo category currently operating anywhere in the world carries that kind of weight. Then there's speed. A cruise velocity of 550 kilometers per hour puts the R6000 in a different conversation entirely. Most cargo helicopters operate at roughly half that figure. Many turboprop transport aircraft don't significantly exceed it. This machine moves at speeds that compress distance in ways that redefine what autonomous delivery actually means at scale. Range is where the numbers become genuinely staggering. 4,000 kilometers of operational reach. That's not a regional platform. That's a machine capable of connecting entire island chains, crossing open ocean corridors, and reaching isolated territories that conventional aviation serves poorly or not at all. 4,000 kilometers means that infrastructure poverty stops being a barrier. Add an altitude ceiling exceeding 7,600 meters and the picture expands further. Above most weather systems, over mountain ranges that ground transport cannot cross, operating in conditions and at heights that eliminate entire categories of environmental limitation. And here's what separates the R6000 from every impressive specification sheet that never became a real aircraft. It has anti-icing systems, all-weather design integration. These are not afterthoughts. They are the difference between a technology demonstration and an operational platform. Individually, each of these figures commands attention. Together, they represent a combination that has never existed before in an autonomous aircraft. Not anywhere, not at this scale, not with this capability stacked into a single platform that needs no runway and no crew to operate. That combination is the entire point. The specifications are extraordinary, but specifications are just potential. The real question is what this machine was actually built to do. And the answer to that question is where the R6000 stops being impressive and starts being important. Start with the most obvious limitation of conventional air transport. Airports, runways, ground infrastructure that costs billions to build, decades to develop, and simply does not exist across vast portions of the Earth. Remote communities, offshore industrial platforms, island chains, mountain territories, disaster zones. These are places where the world needs air transport the most, and where traditional aviation consistently fails to deliver it. The R6000 was designed specifically for that gap. No runway required, no prepared surface, no ground crew infrastructure. It arrives, it delivers, it departs. That capability alone rewrites the logistics equation for every environment where conventional aircraft cannot operate efficiently. Cargo delivery is the foundation, but the platform goes further. Configurations have been developed that allow the R6000 to carry between 6 and 12 passengers, depending on mission requirements. That transforms it from a cargo solution into a mobility solution, connecting people across distances and terrains that currently have no reliable air link. The medical evacuation concept is where the human stakes become impossible to ignore. Stretcher configurations, medical personnel on board, operating in regions that roads cannot reach and where helicopters lack the range to serve effectively. In an emergency, the combination of speed, range, and vertical lift that the R6000 offers isn't just convenient. It's the difference between survival and the alternative. Disaster response sits alongside that. When infrastructure collapses, when roads are destroyed, when conventional supply chains stop functioning entirely, you need a platform that needs nothing from the ground to operate. 2 tons of emergency supplies, 4,000 kilometers of reach, no runway. That is exactly what the R6000 brings to a crisis. None of this is accidental. This aircraft sits at the center of China's national low-altitude economy strategy. A deliberate vision for distributed, autonomous, flexible air logistics that replaces the hub-and-spoke model with something faster, smarter, and far harder to disrupt. For decades, autonomous aviation meant one thing: observation. Cameras pointed downward, sensors collecting data, unmanned aircraft circling overhead, watching events unfold but never intervening in them. The drone was a witness, never a participant. The R6000 ends that era. This aircraft isn't designed to watch anything. It's designed to move things, heavy things, across vast distances, autonomously. That shift sounds simple, it isn't. It represents a fundamental reclassification of what unmanned aviation is actually for. And once that reclassification happens, the entire industry has to follow. Consider what went into building this machine. Domestically developed engines, advanced composite materials engineered for the structural demands of heavy tiltrotor flight, flight control systems precise enough to manage the enormous aerodynamic forces involved in transitioning between vertical and forward flight modes at this scale. China didn't assemble this platform from borrowed technology. They developed the core systems internally and integrated them into something that has never existed before. That engineering achievement matters beyond national pride. It demonstrates that the technical barriers to heavy autonomous tiltrotor aviation are not theoretical walls. They are problems that have been solved. And once something has been solved, the conversation shifts from whether it's possible to who does it next and how fast. That competitive dynamic is significant. Aviation history shows consistently that when one program achieves a genuine breakthrough, it pulls others forward. If China brings the R6000 into regular operational service, aerospace industries in the United States, Europe, and elsewhere face a choice: respond with programs of their own or cede an entirely new category of aviation to a single competitor. That pressure accelerates innovation in ways that decades of theoretical research cannot. Challenges remain, and they deserve honest acknowledgement. Certification frameworks for autonomous heavy aircraft don't fully exist yet. Long-term reliability across thousands of flight hours remains unproven. Operational costs at scale are still unknown. But none of those challenges change the direction. Aviation is moving toward autonomy, toward infrastructure independence, toward flexibility that the runway-dependent model simply cannot provide. The R6000 isn't a prediction of that future. It's the first physical proof that it's already arriving. The R6000 has already done something most ambitious aerospace programs never manage. It has moved from concept to advanced flight testing with demonstrated capability. Stable hovering, controlled forward flight, successful transitions between vertical and horizontal flight modes. These aren't simulations or laboratory results. They are real flight test milestones achieved on a real aircraft that exists right now. But flight testing is a beginning, not a finish line. Full operational deployment requires certifications that don't yet have established frameworks for aircraft in this category. It requires reliability data accumulated across thousands of flight hours in real operational conditions. It requires maintenance infrastructure, operator training systems, and regulatory approval processes that autonomous heavy aviation hasn't fully navigated anywhere in the world yet. Those milestones are ahead, but the direction is no longer uncertain. When the R6000 reaches operational maturity, the applications waiting for it are already clearly defined. Logistics companies operating across archipelagos and remote territories, national emergency services needing rapid heavy payload deployment without infrastructure dependency, offshore energy platforms requiring regular resupply across open water, island communities currently dependent on infrequent and expensive conventional air service. Every one of these represents an immediate market that existing aviation cannot serve with the combination of speed, range, payload, and flexibility the R6000 offers. And then there's the response it triggers beyond China's borders. Programs in the United States have explored tiltrotor technology for decades. Europe has its own advanced aviation ambitions. The moment a competitor demonstrates operational, heavy, autonomous tiltrotor capability, Those programs face urgency they haven't had before. The R6000 isn't just China's next aircraft. It's a starting gun fired at the entire global aerospace industry. The broader low-altitude economy vision extends that further. A future where distributed autonomous aircraft networks replace centralized airport dependency for entire categories of transport isn't a distant concept anymore. It's an infrastructure model that the R6000 makes technically credible for the first time. The question was never really whether heavy autonomous tilt-rotor aviation would happen. The question was always, who would prove it first? That question now has an answer. The R6000 isn't a drone. It isn't a helicopter. It isn't a cargo plane. It's what happens when every limitation those categories accepted gets rejected and rebuilt from the ground up. Vertical lift, autonomous operation, 2 tons of payload, 4,000 kilometers of reach, no runway, no crew, no infrastructure dependency. That combination has never existed before. Not anywhere. Not at this scale. For decades, unmanned aircraft watched the world from above. The R6000 was built to move it. China didn't just reveal a new aircraft, they drew a line between the aviation that existed yesterday and everything that comes next.